Hello everybody. Today I'm going to be showing you how to use the BGP Local Preference attribute to influence route selection. Okay, firstly, maybe some of you here don't know how BGP basically works, so I'm just going to assume you know something about static routes. The first thing to know with what's going on this diagram that I've got on the screen is this first circle here represents for instance, like the company where you would have some control, and this whole company falls under autonomous system 10,000. Here in the middle, we've got three different autonomous systems, which represent three different companies. For example, the first one is autonomous system 100. This one is autonomous system 200. The other one is autonomous system 300. Now, all the routers of one company would all fall under the same autonomous system number. And then here at the top, I've called this imaginary internet because this is where I'm going to have my routes, which are just loopback addresses inside autonomous system 9000 originate from. So just to give you an idea of how this actually works, here at the bottom I've got a PC, which you could assume is a customer connected to this internet service provider that belongs to autonomous system 10,000. Now, one other thing I just want to point out here quickly is you see at the bottom I've got some other numbers like 64,512 and 64,513. These are private autonomous systems that appear with inside this bigger autonomous system 10,000. Basically, it's just a way to break up your autonomous system into smaller pieces to make it more manageable and make the configuration easier to set up. And this is known as a confederation, where you have private autonomous systems within a bigger public autonomous system. But anyway, let me just show you. Let's show you from this R8 router what's going on here. So if you want to see all the routes that are sitting in the BGP table, which is not the same as you see if you type show IP route, this gives you all the routes in your routing table. But if you want to see the routes that are in the BGP table, and only the best routes in the BGP table will actually be put into the normal routing table. So let me just show you how we see that. So we go show IP BGP, and this shows you your routes in the BGP table. So I just want to show you the routes that originate from autonomous system 9000, because this is where we're going to try and influence. We want to make some changes. Let me just show you what's going on. So here we've got this is where we can make changes, autonomous system 10,000, and obviously to reach autonomous system 9000 we need to go via either autonomous system 3000, autonomous system 300, autonomous system 200, or autonomous system 100. So we want to see how we're going to influence using the local preference whether our which path our routes will take to get to autonomous system 9000. Okay, so if I type here show IP BGP, you type reg exp, now we can use a regular expression which is going to act on these autonomous system paths. You see in these routes you've got this path at the end. This says this route originated in 9000, autonomous system 9000, this one here. I'm moving my mouse. And then this route went through autonomous system 100, that's here, and then it went through the private autonomous system 64512. We know it's a private one because it's in brackets, and then it got to us here. We're at router 8. There we are here. So by doing show IP BGP reg exp, we can use a regular expression to show only the routes that originated from autonomous system 9000, because if you look here, the end part of this autonomous system shows you where the route originated. So for example, this route here originated in autonomous system 300. This one here originated within our confederation from the private autonomous system 64,512. So the regular expression we put here is we put an underscore, which can represent the beginning of input, but in this case we're using it to represent a blank space. So underscore can be beginning of input, end of input, or a blank space, or a comma. Okay, but in this case we're using it to look for a blank space, such as, for example, this blank space here between 100 and 9,000, right? Then I put here 9,000 because we're looking for routes that originated in autonomous system 9000. And then in this case it wouldn't make a difference because I don't have anything behind autonomous system 9000. But if you want something that originates in 9000, you have to put the $ at the end, and the $ represents the end of the string, the end of the input, meaning if anything else appears after 9000, it's not going to be in this output. So the command is show IP BGP reg exp underscore 9000 the $. You can look up regular expressions on the internet if you're looking for more of these to see what options there are. Let's press enter here. So here you can see all the different routes that are originating from autonomous system 9000. And what you'll notice is, let's take the top one for instance, this one here. Sorry, my mouse is giving a bit of hassle. It originates in autonomous system 9000. It then goes through autonomous system 300, and then it goes through autonomous system 64512. So I'd like to, for this example, show you how we can influence this route at the bottom here. Let's assume this is Google or YouTube. So this route is 216.58.223.0, and it's /24, and it's currently going, it's originating from 9000 and it's going via autonomous system 300 before it comes into us. So I just want to see what is the IP address for this 216 route that I'm going to use, 216.58. So we're just going to go, yeah, this is autonomous system 9000, and I've already done a show IP. I'll just do it again so you see it. Show IP interface brief. You can see 216, this one at the bottom, loopback 6, 216.58.223.14. So that's the imaginary, that's what's creating this imaginary route of 216.58.223.0/24. So I'm going to ping that IP address from this PC1 here in the corner. Now this PC1 is connected, you could think of it as like a client of this internet service provider that falls under autonomous system 10,000. So if you were in here, you can do a trace route to 216.58.223.14. And just to show you what's going on here, so from the PC's perspective, the first IP is 196.192.88.2. So you're just going to have to trust me on this. That is the first hop here, which is router 8. The next one is 196.192.95.5. That is router 5, this one here. I've actually used 196.192.95 on all these routers here, and this last number matches the router number. So this is 196.192.95.5. So basically we started from PC1, hop to router 8, goes through the switch, router 5, right. Then we go to 11.11.3.1, which means we're going through autonomous system 300, and then from there we go to 12.12.9, which is here, and that other IP originates from this router as well, the 216.58.223.14. So assume, for example, that you're working at this internet provider that falls under autonomous system 10,000, and you find that your uplink through this other provider which falls under autonomous system 300 is totally saturated, meaning most of your internet is running through that provider. So you'd want to move some of your routes to another provider. So in this case, I'm thinking, well, let's move to autonomous system 100. We want to make it so that if you do a trace route from PC1, instead of it going via autonomous 300, we want it to go via autonomous 100. Now look at this IP here. That's 11.11.3.1. That's how I knew it went through autonomous system 300. So it would have to go to 11.11.1.1. Then we'll know it's going through here. Okay, so first things first. How are these routes chosen? Well, I'm going to show you these routers on the edge here are always going to pick the shortest autonomous system path. So if I go here, show IP BGP, and we use that reg expression, so we can look for the routes that originated in autonomous system 9000. $sign for the end of the input. Okay, the one we're looking for is this one here. So the best route is going to be the one with it. Let me just show you how we know that. So this greater than sign means best route, and the star means a valid route. So for the 216.58, you see that the best route is via 3.3.3.3, which from the perspective of router 5, okay, 3.3.3.3 is this router. So from its perspective, and you can also see here, it goes from autonomous system 9000 to 300. So from 9000 goes to 300, and then it gets to router 5. So from router 5's perspective, this is the shortest AS path. So let's look at the same route from router 6 perspective. So from router 6 we can go show IP BGP, and let's use the regular expression to just show routes originating from autonomous system 9000 and not, you know, routes that are also originating from autonomous system 100 or 200 or 300. So here we put in, sorry, that's for beginning of input, so that's not going to work in this case. So we can just underscore, which represents a space, 9000. Could do another space as well, in this case also works. But that would not show things that originated in 9000 in the real internet, because it would show things behind it as well, but there's nothing behind it here. So here we've got the route again, and it's this is the 216.58.223, and now it's showing this one is the best. You see, everything I've highlighted here, those three lines are all routes to get there. For example, if you take the top one, which is in this case what's the best from the point of view of router 6, we come through autonomous system, we originate in autonomous system 9000, that's where the route comes from. Then it comes through autonomous system 200, and then it gets to us at router 6. But we could have also come through, well, if this route goes bad, then the next one of the next routes will get put in, which either goes from 9000 to 100 or 9000 to 300. Okay, so let's move on to router number 7. So on router number 7, let's do the same thing. We're in global configuration here, so just type end to get me back to privilege mode, and we go show IP BGP reg expression. underscore. We're looking for routes that originate in autonomous system 9000, and there we go. We've got the 216.58.223.0, and we see the shortest path, which is this one here. You see there's your what do you call that thing, a greater than sign. It says it came from 9000 and it went via 100. So what are we seeing here? We're seeing that from the point of view, for example, router 5, this is the shortest path via router 3. From the point of view of router 6, the best path is via router 2. And from point of view of router 7, the best path is via router 1. Now, obviously, the PC at the end of the day is going to get one of those routes. So if we take one of these routers here at the back, which are not directly connected to the uplink ISPs, then let's see what we see here. So here we can go show IP BGP reg expression, and we're looking for stuff that originated in 9000. I'm just going to go quite quick here. And for this route that starts with 216, we're seeing we come via 300. Let's check this one here. Just pop in my password quickly. Show IP BGP reg expression underscore 9000 $sign, and again we see came through 9000, then 300. So we're using 300 there as well. And let's check what's going on here, which should be the same. And then we see our 216.58.223.0 route is going via 333, which is again, you know, it originated in autonomous system 9000, went via the route was then advertised to autonomous system 300, and then to us at our private autonomous system, which is part of the confederation, 64,512. Okay, so now here's the whole reason you would want to be here and see how can we influence this route to go via autonomous system 100. So we come to router 7, which is the router that is connected to our uplink. Now if all of these were all coming into the same router, you could do this as well. So first thing we need to do is match this route. Now how can we match it? Well, you've got an IP access list, and you can match it by IP. You can do a prefix list, which I'm not going to explain how to do that in this video, but just let you know that. So that can specifically match those routes, or we could match all routes from that autonomous system by using an AS path access list. In other words, we can use an access list that matches to these paths at the end, and then we could match all routes that originated from autonomous system 9000. Okay, but before I get there, let me just explain something. So how are we going to choose, or how does BGP choose its routes? Well, the first thing BGP looks at when we look at these routes, and let me just get there, just scroll up here quickly. You see we've got this thing called the weight. Now you'll notice the weight here is 000. So routes do not carry this weight attribute through the internet, but on a router an administrator can set an access list or something like that to identify a path, and then we can assign a weight to that route, and that weight will influence that route on that router. But when the route gets passed on to another router, it gets set to 0 again. So the first thing the router looks at is which route, if the routes are, let's say, equal, meaning if you got two routes and the route can't tell the difference because they both have the same subnet mask, first thing the router is going to look at is well, sorry, this is for BGPs. Our BGP is going to tell which is the best one, because remember, once BGP's got the best route, that route still has to compete to get into the routing table. But from BGP's perspective, first thing it needs to check is which route has got the highest weight. Okay, and that one will be the chosen one if the equal subnet masks. The second thing it's going to look at is local preference. You see this thing here, which by default we're seeing 100 everywhere. So if you influence the local preference, it's a little bit different to the weight, because I could, for example, set the local preference on router 5, and that will be passed on to router 8, router 9, router 11. And then obviously if the router, so if the route doesn't get chosen for the best weight or the best local preference, then the router looks at which is the locally originated route, meaning the route came from that router, and then the fourth criteria it will look at, which is often the one that it uses, is the shortest AS path. It looks at which one here is shorter, which is not doing much in my diagram here, because pretty much the AS path in this diagram is the same. Whether you go through autonomous system 300, autonomous system 200, or autonomous system 100, the path length is the same in my diagram. So I've decided we're going to use an IP access list on router 7, and we're going to use this access list to match the 216.58.223.0 route, and we're going to assign a local preference to this route. Now, just to show you before we start, there's the route, and as you can see, the local preference is 100, which is not making it any better than any other routes. So first you need to go to global configuration. We're just going to do a standard access list. So you go here, IP access list standard, give it a number 1, and then I'm going to go permit 216.58.223.0, and our wildcard mask is 0.0. You basically take 255.255.255.255, 4 sets of 255, and from that you subtract your subnet mask, which is 255.255.255.0, and that's how you get your wildcard mask. That's what that is. So this access list will match the route we're looking for, 216.58.223.0. Okay, so let's get out of that. I just type exit. So there we're back at the global configuration. And now I need to put this in a route map. So you type route map, give it a name. In this case we're just going to call it, yes, I didn't think of this one, but let's try route prefer. And your route map's going to have match and set statements. So in this case, what must it match? It must match an IP address. Let's put a question mark to see how we're going to do this. We're going to match the IP address based on, if you see here, there we can use access lists. So we're going to match it based on our access list 1, which we've just made. And then you type set, what we want to set when that happens, and we want to set the local preference. And let's set the local preference. We can set it to any number in that range, which I think is, let's see, 4 billion something. So let's set the local preference just to 1,000. Okay, let me just get out of here a second. So we've done the route map. I just want to show it to you. So you can type here, let's just use it, do show route map. So what is this route map doing? Well, here it is. We've got this match clause. It must match access list 1, meaning if the route matches 216.58.223, then set the local preference. Now there's still a problem here, because we're going to end up dropping routes that don't match this access list. So we need to add another line to this route map. So we're going to go route map, and we need the same name again. So it's route prefer, and then we just say permit 20. Now how do I know permit 20? Well, look here, we've got sequence 10, so let's do the next 10 sequence. Okay, so let's just show you that again. Show route map. So now we've got our sequence 10 in our route map. So there's your match clause. If it matches your access list 1, and set the local preference to 1000. And well, if it doesn't match, this route map should still let things through. That's why we have this permit 20 here, and so it will match nothing, set nothing, but it'll still allow things through. So now, remember we're on router 7. We need to apply this route map, which is basically the route map is using an access list to match the routes, but on its own the route map does nothing. So we have to attach this route map to our neighbor here in Autonomous System 100. So let's go there quickly. First I'm going to show you the current configuration. So do show run, that's showing you the run config, and we want to pipe that into the section router BGP. So it's going to show our current BGP configuration. R1 is currently this neighbor 1111. Okay, so this is the statements that we use to connect to this neighbor. Neighbor 1.1.1.1 remote autonomous system 100. EGP multi-hop, that's because we're connecting to a loopback address, so we need to tell BGP this route is not 1 hop away, it's 2 hops away, because we are connecting, for example, on this, physically we're connecting to 11.11.1.1, but through BGP we're connecting to the loopback address, so that's why we have this EGP multi-hop. And then we've got this last one, neighbor 1.1.1.1 update source loopback 0, basically saying when router 7 talks to the neighbor, talk from your loopback address, so that router 1 is talking to router 7 on its loopback. So anyway, it's just to make that work. So let's apply this route map. So we need to go into this BGP session. So you type router BGP, and the session is 64512, and then you go neighbor, and we put in the neighbor's IP address. You type route map, and we give the route, type in the name of the route map, which I seem to have lost it. Let me drag this thing a bit bigger so I can see what I'm doing here. Route prefer, and this is case sensitive, so you must remember that. Got to type it exactly how it is, route prefer, and we're using this route map inwards. What does that mean? It means when Autonomous System 100 sends us routes, these routes must be filtered through the route map called route prefer. And what's that route map going to do? Well, it's going to use that access list to look for that specific 216.58.223 route and set the local preference to 1000. So there I've applied that route map. Now I just want to write the configuration changes. It's not doesn't make a change right away. If you go show IP BGP regular expression, let's put it in here. Sorry, wrong one. We see our route still has a local preference of 100. So first thing we've got to do is clear the neighbor session. So we go clear IP BGP, put in the neighbor session. Now, in order that not all the routes are thrown away, because this can cause a real problem on your network, if you just pressed enter here, you would clear all the BGP routes from that neighbor, and it could take 15 or 20 minutes for them to come back up, and in the meantime your customers are going to be sitting with internet problems. So what you need to put on the end here is soft in. So it doesn't mess up your routing table. So now if we do this, I'm just using the up arrow key here, show IP BGP reg expression. If you're looking for that route again, there it is. Sorry about that. You see now the local preference is 1000. So if we were to go to, let's say, so we were on router 7, right? And we've now set a local preference of 1000 on this link that goes via autonomous system 100. So let's say we go to router 5, and we do this again, show IP BGP reg expression. Okay, there you see the local preference is 1000 as well. It's been carried through, and you see now this has been chosen as the best route, even though from router 5's perspective, this was its best route previously. So I seem to have confused myself. This was the best route previously because this is the route here. Previously it would have gone via autonomous system 300, but now it's going to go via autonomous system 100 because we've given it a local preference of 1000. And if we come back to one of these routers at the back here, okay, so you see previously there was your local preference of 100. Press enter here. There you see the local preference is 1000. So within your autonomous system, all your routers will share this local preference. It won't be passed on when you connect eBGP wires to other autonomous systems, but within your own autonomous system. Anyway, so let's go back to PC1 and do a trace route. So you go here. So you notice the first time round, hop number 3 was 11.11.3.1. That was via autonomous system 300. So now we're going to try this again, and we see hop number 3 is 11.11.1.1, which is via autonomous system 100. So that is how you can use local preference to influence the route selection. And just to basically go over that one thing again, in order to choose the route, you can use an IP access list or a prefix list. If you would like, for example, to set the local preference on all routes originating from a certain autonomous system, then using an IP AS path access list would work in that situation. Anyway, that's all I have to show you. Thank you for watching.